In last videos we discussed about the motion of car on horizontal circular road and on banked road. So now let us solve this sum related to those topics. It is given that a car of mass 1000 kg takes a circular turn of radius 10 meter and the speed of the car is 5 meter per second. Now the question is that will it be possible for the car without skidding? That means will the car be able to take the circular turn without skidding? It is given that the coefficient of friction, that is the value of mu, is 0.1 and g you are asked to take as 10 meter per second square. Now we know that this condition is applicable in this type of cases. That means the velocity of the car should be less than equal to root over mu rg. If it is so, then the car will take the circular turn without skidding. But if the velocity of the car is more than this value, then the car will skid. So that's what we have to see here. So v is given 5, this one. Now let us see what is the value of root over mu rg. Okay, so mu is given 0.1, r is 10, g is also 10. If you calculate, the value comes as 3.16 meter per second. So that means this is the maximum limit of velocity. If the car can move with this much velocity or less than this, then the car will be able to take the circular turn without skidding. But the velocity of the car is 5, which is more than 3.16. Thus this condition is not satisfied. Instead we are getting this thing. Okay, so that is why the car will skid. Okay, I think it is clear. Then next topic is apparent weight of a man in a lift or elevator. Okay, that means when a person moves inside a lift or elevator, in that case the weight of the person, it gets changed apparently, and how it gets changed, that one will see. Okay, suppose whenever we stand on a weighing machine, the weighing machine gives us the weight, right? Actually when we stand on it, our weight, suppose this is a weighing machine, if something is there, some person or maybe some object, okay, whose weight has to be measured, its weight is actually acting in vertically downward direction, that is W, which is equal to mg. Okay, at the same time this weighing machine, it is exerting a reaction force on the object which is in upward direction, r, and for horizontal surfaces this r and this weight are equal. So in other words, actually this weighing machine is measuring the reaction force applied by it on the object or on the person. It is not actually measuring the weight, but since for horizontal surfaces this r and weight are same, that is why though it is measuring r, it is giving us the weight. I think it is clear, right? A person is standing on a weighing machine, the weight of the person is acting in vertically downward direction. At the same time, the weighing machine is exerting a reaction force on the person or object on upward direction, which is r. If the surface is horizontal and if this thing is not in motion, if the whole system is not in motion, then certainly weight and r will be equal. That is why though the weighing machine measures reaction force, it gives us weight. Okay, now what happened is, if a person is standing, suppose this is an elevator or lift, just a second. Okay, if the person is standing inside an elevator and the elevator is now moving not with a constant velocity but with an acceleration a in upward direction. Okay, in this case what happens is, the weight of the person is acting in vertically downward direction, that is W equals to mg. Reaction force is vertically upward direction, that is r. But since the elevator is moving in upward direction, this reaction force and weight are not same. One is greater. Which one is greater? R is greater. Since R is greater, As a result, the whole thing is moving in upward direction. Okay, fine. Now in upward direction it is moving with how much acceleration? A. So if A is the acceleration, what is the force associated with it? F equals to ma. M is the mass of the person. This much force is associated with the acceleration. This force is in which direction? In upward direction, because the acceleration is in upward direction. So can we say here that two things we got here. One is r is greater than w. How much greater is that? How we will do that? If we subtract r minus mg or w, because r is greater, so if you subtract, we are going to get some force. What force we are going to get? This is the remaining force. That means that should be equal to ma. Is that clear? I think it is clear. See, once again I am repeating. The person is inside the elevator, weight is in vertically downward direction, reaction is in upward direction. In this case, reaction will be greater than the weight because the whole system is moving in upward direction. Now how much greater? Reaction is greater than weight, no doubt, but how much? By which amount it is greater? So for that we are supposed to do the subtraction, r minus mg, and the result of this subtraction will be a force only, no, because this is a force, this is a force. If you subtract, the result will be another force. Which force is that? The force associated with the acceleration, ma. So that should be equal to ma. Alright, this is the equation I have written here. Okay, this one. Alright, so from this, mg will go that side, it becomes m common. If we take, it will be a plus g, so we get this equation. Now see, in the previous case, means when the elevator was not moving, in that case r was equal to only mg, but since the elevator is moving with an acceleration a, this time r is equal to mg plus ma. That means r means what? I told you that this is the weight, this is the apparent weight, because as we when we stand on a weighing machine, which quantity the weighing machine measures? It measures the reaction force, r. So in this case, if the person inside the elevator stands on a weighing machine, this time the weighing machine will not measure only mg, but it will measure mg plus ma. That means the weight of the person apparently has increased by this amount. Initially it was only mg, but this time it is mg plus ma. So the conclusion is that thus apparent weight will increase. Okay, if the same thing happens but in downward direction, that means this time suppose the elevator is moving in downward direction with acceleration a, then in that case the force F will also be in downward direction, and in this case W will be greater than R. In the previous case R was greater than W because it was moving in upward direction. Here in downward direction, so W minus R will be equal to MA. In the previous case it was R minus W, mg means W only, you can write W also, not a problem. So R minus W was MA, this time W minus R is equals to MA. So if it is so, R will be equal to W minus MA. Now W means it is mg, so mg minus MA, or we can write it like this. Now see, initially when it was not in motion, R was equal to only mg, but this time mg minus MA. So minus means what? It is reducing the apparent weight, which is R, it is reducing in this case, or it will decrease. By which amount? By MA. Okay, three more cases are there of this this elevator problem. That one we will discuss in next video. Thank you.